Now let's do a problem. Suppose a 2-kilogram object is connected to a spring with a force constant K equals 50 newtons per meter, and it rests on top of a table. The coefficient of friction between the mass and the table equals 0.1. So I'm going to start writing this. I'm going to say the mass is 0.2 kilograms. And K they give me is 50 newtons per meter. And they give me mu equals 0.1. And they ask me what is the frictional force between mass and the table. Mu times N, where N is the normal force, and N was given as mu mg. Do you have mu? Do you have M? Do you have G? Plug numbers in and let me know. It will be 0.1, 0.2, and 9.8. Anyone have an answer for me? Say that again. 0.196 newtons. Okay, now comes part B. In this part, it says calculate the total distance that the object travels if it is released from 0.1 meters away from equilibrium. So I know my formula for work. Work equals force times displacement. In this case, my force is the frictional force. I am looking for D. What is my frictional force? 0.196 newtons. And I am looking for my D. The problem is I don't know this. How do I find that? So I have to find work. I gave you a formula, this one, that was delta E equals work. That's a formula I have. So all I have to use is use that formula to calculate work. What is my delta E? My delta E is potential energy final minus potential energy initial equals the work. Let me start by potential energy initial. How do I find potential energy initial? It is a mass spring system. So it'll be 1/2 kx squared. And it told me the x was 0.1. So that's easy. All I have to do is plug that into here. And it gives me 50 for my k, 0.1 squared. And that gives me my answer. Somebody come up with answer? 0.5. And the unit will be joules. Now, since I'm looking for the final, I can't use potential energy final as 1/2 k x final squared because I don't know this x. I have to find it. So in order to find this x, I have to do something even more funny. So xf is something I don't know. So I have to use another formula that we've been using before, which is the spring force equals the frictional force. And what was the spring force? Kx. And what is my frictional force? 0.196 that I get from part A. And what was my K? 50. X equal 0.196, which will give me my X to be equal 0.196 divided by 50. a tiny number. 392. Oh, meters. Thank you. Oh, excellent. So this means I can plug this value for my X into here to give me potential energy final as 1/2 K 0.0039 squared, or 1/2 50 0.0039 squared, or potential energy final 0.004. So now I have values of final and initial. So can I put the values from 1 and 2 in here? What will I get? Potential energy final will be 0.004 minus potential energy initial will be 0.5. Yeah, so this is from 1 and this is from 2. And I'm going to get a negative number. So I'll get like a negative 0. Wait, hold on. This should be 2.5. This should be this. Can someone confirm for me this thing I'm putting underneath? 1/2 50 times 0.1 squared. It's 2.5. Yeah. So this would be 0.2. Louder, please. Joule. So once I have this number, that's for my work. I can plug that back into here. So then I will have work equal 0.196 times D, or negative 0.246 equal 0.196 D, or D to be calculated as negative 1.27 meters. And what does a negative sign represent? That it is moving opposite to the direction. That's all that means.